Alright, so in this video we're going to go over how to map memory. To start, we went over diagramming last time in the last video, and I'm calling this memory mapping, and they're a little bit different because when we are mapping memory, we're a little bit more interested in thinking about where the memory is stored on the computer, like whether it's within some stack frame or whether it's in something like the heap. And so as opposed to diagramming, which is more like diagramming out what the data structure looks like and how it's stored and how it's linked, where you maybe don't care so much about exactly where the memory is. So you kind of need a memory map when you're starting to look at like copy constructors, equal operator, and that kind of thing when you're moving around memory. Sometimes it's really necessary to think about it in a deeper level and actually look at where the memory is stored. So we're going to start by a simple example of just what memory looks like when you pass by reference versus pass by value. So pass by value is the default in C++ for function calls, and it makes it so that C++ makes a copy, right? So for this kind of simple example that we're kind of warming up with, you have a main, you are initializing a variable I to 0, and then you're passing that into f, and so f is getting called, I is getting sent in, but because it's passed by value, it's just going to make a copy of I and store it locally as x inside of this stack frame for this function call. And then inside of f, all that happens is g is called. So then g is also passed by value, so y is going to get a copy of x. So again, now you have 3 copies of that same variable I that you started from. And here, this local copy is in its own stack frame, and so here we increment it because y++. But then as you move back down into main and go out of g, out of f, these stacks are just destroyed as you move down, and all that's left is the original I that never got touched. When you pass by reference, by adding the ampersand to the parameter declaration, then what happens is that C++ will make a pointer and point to the original object. So what that looks like in memory is, again, we initialize 0 and then we put I into f, but then x is just going to create a pointer that points to I, and then x is called, or g is called, x is passed in, y is also passed by reference, so it's going to refer to x, but since x refers to I, it's just going to refer to I. So when you increment here, it's actually going to increase the 0 to a 1, and then when you go out of those functions and destroy those stacks, you're destroying the pointers, but you are maintaining that I is going to be changed because it's in the original stack. Or it's in the original memory from the main part of the stack. So this is the basic idea of how it works. So when would this come into play with writing classes? So we're going to do the same thing, but now we're going to do it with an object and see how that looks different. So what do you think happens when our vector is passed into f by values? This is another example here. We create a vector using our vector, we push back a value, and then we call f and send that object into f. So a couple different options here. So let me start by explaining what would happen if there was no copy constructor. So if you wrote this class and you did not include a copy constructor, that just wasn't included at all. So let me label that. So this is no copy constructor. You would get B. And so what's happening is that in main, you are creating the object, and so the object has 3 data members, right? It has a capacity, a size, and a C array. The data member is actually a pointer to the front of a C array, so that's what you can see here, is that this is pointing to an array that's allocated on the heap because we used the new keyword, and so this is what you get in main. When you call f by value, what it's going to do by default, what C++ is going to do is it's going to make a copy, right? That's the default. Pass by value makes a copy. So here it made a copy. It made a copy of size, capacity, and it made a copy of that pointer. But it did not make a copy of what it pointed to. So here you have a copy, you have a second pointer that's pointing to the array that you made on the heap. So the problem with this is without the copy constructor inside of F here, if you change the v2 object, it's going to change the v object that's in main. So that's not what we want, and so that's why you have to write a copy constructor, and that's why you have to think about how your memory is mapped. So if you add a copy constructor, you get A, and what happens here is that the copy constructor not only makes a copy of all of your data members, but it also makes a copy of any of those dynamically allocated arrays, which is what you can see here. And so now you have two sets of those arrays. So if we change v2, v2 will update just this one, but the main function will remain unchanged. So what's C, you might be wondering, when does that happen? So this is an example of what happens with pass by reference. So when you pass by reference, the v2, which is adding the ampersand here, the v2 is just going to point to the object that was just declared in main directly, and so then it will have no copies of anything. It will point directly to that object. And remember, that's kind of what happens under the hood of pass by reference, is a pointer to whatever you are passing in is created. Okay, so this is pass by reference, this is pass by value, but without a copy constructor. Pass by value, and this is pass by value with a copy constructor. So let's talk a little bit more about the copy constructor and why a copy constructor is needed, and it can really help you understand this memory mapping. As I said in the previous example, C++ will require a deep copy when you're using pass by reference, or sorry, pass by value. So if a class contains member variables that are pointers, then you actually need to go through and copy everything that that pointer is pointing to. So that's all a copy constructor really does. So if you look at the R vector copy constructor, this is what it looks like. This is what it's copying, other, it's the parameter that comes in, and then this is the new object that it's creating. So the first step is that you just need to allocate space based off of the old capacity. You set the new size to the old size, and you set the new capacity to the old capacity. And then you just need to go through and copy all the elements from the one that you're copying to the new one. And that's the basic idea of a copy constructor. And with a copy constructor, you're not destructing the other one. You want to keep it, and so you shouldn't delete anything in the copy constructor. And so when you actually call a function and pass in a object into that function, and it's passed by value, and it needs a full copy, what it's actually doing is it's calling a copy constructor which looks like this. And what that says is make v2 and make it a exact copy of v, but make it a deep copy. And so in this case, in this code, for this example here, v is this, and v2 is the one that you're copying. No, I have that mixed up, sorry. So in this case, v2 is the new one that you're creating. It's it's the one that's getting created, it's the copy, right? And then the original one is v, and so other is v. So what this code is doing is, we know v is basically, it has these three member variables. It has 1, it has a capacity of 4, and then it has a pointer that's going to point to 9. right? So that's what V looks like. So what the copy constructor is going to do is it's going to create this V2, which is this, and it's going to start by, creating all those member variables, and this first line here is going to create a vector that's the same, or a C array that's the same capacity. It's going to fill in the size, which is 1, and then it's going to fill in the capacity, which is 4. And then this step here is going to copy over. So this vector only has one thing in it, so it's going to copy the 9 over. So that's kind of what these 4 steps, I guess, do in the copy constructor. And so this is other in there. So that's what the copy constructor looks like in memory. And so that's why it's so important to do this memory mapping. So this last slide here is really what's important to understand, is what these different memory maps look like for copying with a constructor, with a copy constructor, copying without one, and then passing by reference, what that looks like. So I hope that helps kind of see what memory mapping looks like. And yeah, that's it for this video.